Okay, so let's look at interannual variability in tropical cyclones. We have already implied it by saying there is modulation by El Nino and La Nina, for example, in the Pacific, Indian, and Atlantic Oceans. But in reality, things are not usually that simple. In a composite sense, if you look generally at the characteristic of tropical cyclogenesis and tropical cyclones during El Nino, you can find some systematic differences, let's say in the vertical shear on the Atlantic side versus the northeastern Pacific and the Indian Ocean. But when you look at individual years, here is 2004 sea surface temperatures in May to November, 2005 and 2006, and you can see clearly there are differences in the distribution of the warmest sea surface temperatures in all three oceans actually. But if you look at the years in terms of tropical cyclones, you don't even know which year is which. The relation is not that simple. When a major hurricane hits, you cannot say that had something to do with low frequency variability of climate modes or something to do with interannual variability of the tropical cyclones themselves. Okay, so I think this is 2004-5 was a monstrous year with lots of cyclones including Katrina, and this is 2006. I took these figures from Wikipedia, but you can also look at this in terms of let's just say tropical storm days, category 1 and 2, 3 and 4 and 5. You expect there are few cyclones that make it to major cyclones, as we talked about before, and there are higher number of 3, 4, higher number of 1, 2, and lots of storms in terms of days here. But if you look at the corresponding El Nino index, this is the multivariate El Nino index North Atlantic oscillation, which we haven't explicitly explained, but it's basically an oscillation between Icelandic high and Azores low, or the other way. Icelandic low and Azores high, I think. Yeah, it's a subtropical gyre, and there is interannual variability which affects the storm tracks as well as shear and so on over the North Atlantic. This is the counts of tropical storms in category 5 and the category 4 and 5. So the relation is not that visible, it's not that solid, it's not something that jumps out, right? Nonetheless, there are indications. This is interannual modulation due to the El Nino Southern Oscillation. So this is year El Nino -1. Typically El Nino starts in a calendar year, let's say around June for a strong one, ends in December, January, February of that year going into the next year. And there are plenty of El Nino related processes, especially below the surface, that start in the year before. Since it straddles years, we tend to look at El Nino -1, El Nino, and El Nino +1. And you can see that in a composite sense there is a difference. So El Nino -1 and +1 look much more active than El Nino, fewer cyclones, and this is shown here for the East Pacific as well, right? So we already talked about how the vertical shear here gets stronger during El Nino and reduces number of cyclones, whereas on this side, on the northeastern Pacific side, the opposite happens with reduced vertical shear, so more cyclones. And we have to keep in mind that this region we have often related to the easterly waves coming off West Africa and crossing over into this region as well. Okay, so this is El Nino +1 and El Nino -1. Okay, in other words, there are modulations of cyclones by interannual variability, which means we have interannual variability in the cyclones. We looked at something similar for the Indian Ocean as well, and there are also studies for the Pacific, Northwest Pacific, where the El Nino redistributes the warm waters, so the cyclogenesis regions shift and the cyclones travel let's say the pathway of a cyclone is longer during El Nino because more warm waters are spread compared to La Nina. And during La Nina here you get more cyclones on this side and fewer cyclones on the East Pacific side. So you can imagine that there are modulating factors, but the relation is not always very systematic in terms of when you would get a major hurricane hitting coast, for example. So it really depends on how you count interannual variability, because one can also look at maximum winds, maximum sustained winds in the storms based on El Nino and North Atlantic oscillation and so on. There is another major mode of variability called the quasi-biennial oscillation, which has a systematic propagation down from the stratosphere into the troposphere, and it has these westerly, easterly, westerly, easterly phasing at quasi-biennial time scales. So that's why it's called quasi-biennial oscillation. Of course, there is predictability if this is such a systematic downward propagation, because you can see that this is here almost a year ahead of the surface manifestation of the easterly phase. So if there is predictability and that is relatable to modulation of cyclone activity, then it could be useful. So here we have deep easterly phase with minimum storms. So east winds over the surface manifest a little bit later on. So this we are looking at 30 millibar, 50 millibar and 10 millibar. So we are up here somewhere. So you can see there is an impact on the cyclogenesis. So deep westerlies have maximum storms and west winds happen with the phase. So if these relations are systematic, then obviously they can also be used for improving predictions and of course understanding the relation between cyclogenesis and the QBO phases. But the other thing to remember is that cyclogenesis and generation of incipient perturbations disturbances is one thing, but survival and evolution of those incipient disturbances into tropical storms and cyclones and what category they will reach, etc., are dependent on so many details of steering winds, where they will go, ocean heat content, and islands, and so on and so forth. Okay, so clearly there is interannual variability of cyclones and the modulation by low frequency modes of climate variability, but it's still not clear. But for example, if an El Nino prediction comes, which usually has 6 to 8 month leads, then one can say with some confidence that it will be a less active hurricane season and a more active northeast tropical Pacific cyclone season, typhoon season. But beyond that, not easy to translate it to number of cyclones or number of major hurricanes.